Go.
Hello, my dear students, and this is the demo video for our reaction demonstration. I want to do a reaction, a classic chemical reaction for you that is done in almost every chemistry course. Oftentimes it's even done in the junior high, and I've even seen it done in the elementary level, but I want to add a few precautions to it. It probably shouldn't be done until the higher levels because it's incredibly dangerous. So let me turn on the lights and let's go back to the lab and do a quick 5-minute demonstration of this experiment. And then in a separate video, I'll post a discussion and some hints for answering the questions for our lab, which we're going to call the carbon souffle. Let me turn on the light so we have more light in our lab procedure. So, if you read the procedure, it says to be very cautious because we're going to be mixing common table sugar, sucrose, with concentrated sulfuric acid. I can't tell you enough how dangerous concentrated sulfuric acid is. I have a reminder of how dangerous it is, a big scar on my neck from my graduate education at Texas A&M. I was pouring into a little 10 mil graduated cylinder from a large bottle. Some got on my hand and I panicked. It sizzled, burned. I panicked and poured it on my neck and my shirt. I was wearing a sweater, it was winter, and this pullover sweater came off like a cardigan. It just dissolved my sweater. This is an incredibly dangerous concentrated acid, and so I'm going to switch to safety glasses. This is sometimes found on YouTube where people are performing this experiment. They call it the carbon snake. We are going to produce carbon, and it's going to be expanded because there's going to be gases in it that push it apart and make it expand. But it's nothing like the reaction. I think it's between nitrocellulose and potassium nitrate or something like that for the novelty fireworks you buy that are carbon snakes in 4th of July. This is a totally different reaction. This is another type of reaction we haven't studied yet called a dehydration reaction. We're going to take that sucrose and pull the water out and leave just plain carbon behind. So for my sucrose, I'm just going to use regular old table sugar, cane sugar, and I'm going to add enough to this beaker to get it to about the 30 milliliter line. A lot of the videos you see on YouTube are called the carbon snake reaction. I like to call it the carbon souffle reaction because I don't want to make a long snake that snakes out of my beaker, and I'm going to do it behind safety glasses, and I'm going to do it behind a blast shield. This is our new blast shield in the lab that we created. I'm going to take some concentrated sulfuric acid as it comes out of the stock bottle. It's 18 molar. This is a smaller stock bottle that would be appropriate for measuring small quantities out. Once again, I'm just going to take 30 mils. You can see it's kind of syrupy, very concentrated, and there's a drip there. I'm going to wipe that drip off, but just to show you where I wiped the drip off last time I did it, it dissolved the paper and turned it black. Because cellulose is made up of repeating glucose units the same way sucrose is made up of 2 sugar units linked together, a glucose and a fructose, to make sucrose. That's its proper chemical name. And And I'm going to set this aside so it's out of our way. Many of the reactions you see on YouTube and other places, personally I feel are quite dangerous because they're done with too large a quantity. We'll see and observe the reaction just fine here. So if I can get you to zoom in over here, I'm going to go ahead and add this to our beaker. And in class, all the students are wearing safety glasses. And I also asked them to be on the other side of this, not to be looking over it or around it, but through it to ensure that nothing bubbles out and endangers them. So, and I should even actually, if you want to know the truth, be wearing gloves. Here goes. I'm going to give it a little swirl to mix it up completely. And as you can see already, that sugar is turning yellow, and in the bottom, even dark brown. Now, there are drops of sulfuric acid in there. I'm going to dilute it out and dilute it out considerably so that it reaches a safe molarity. At least 1 to 100. That'll get it in the pH above 0 range. Remember, even 1 molar sulfuric acid is pH 0. And really, less than that because it has it's H2SO4. It has 2 hydrogen ions, H pluses, that it can produce. Notice now it's turning black, a darker brown. I will say I wish I could do some video editing because right now it's boring. It is just sitting there reacting. But as it reacts, we start, and you'll see this with a lot of delayed reactions, at some point we're going to reach concentrations or equilibrium amounts or temperatures where the reaction will proceed very vigorously and very violently. In time, the water that's being extracted from that sugar, and notice I did not add any water. That was concentrated 18 molar sulfuric acid, which is over 90% sulfuric acid. Just a few percentage points of water. I want to say it's 97 or 98% sulfuric acid. Definitely over 90%. There's not a lot of water in there, but we're producing water from that sugar. And at some point, the temperature, this is a very exothermic reaction, those oxygen and hydrogen atoms in the sugar would rather be free. And so the energy that it took to put them and bond them to the carbon, the energy in those chemical bonds is being released, and we're getting a great deal of heating. Thermal energy is being released, and at some point it's going to be over 100 degrees, and it's going to boil that water and turn it to steam. And you will see this beaker start to steam. And as we produce that and some other gases, a little carbon monoxide, a little carbon dioxide, and a little sulfur dioxide, you will see those gases fill up with the remaining carbon, basically charcoal, graphite. We're producing graphite. And so it will be expanded because it's going to be full of gas bubbles. I won't say air bubbles because it's going to be mainly steam and some of those other gases. Ideally, this should be done in a hood, but like I say, I like to use small quantities, and we have enough ventilation, fans going, and heating, ventilation, air conditioning going in the room to remove most of the gases. I have a carbon monoxide monitor. If you listen, you can hear it bubbling. Now you can see the steam being generated, and very quickly this carbon will be extruded from the beaker. I use a beaker for a reason. some people use a graduated cylinder, or God forbid, something like an Erlenmeyer flask, because they want to extrude the carbon and make a longer snake. In my opinion, that's not wise, because if I'm expanding that carbon, that graphite that's remaining, in a small, or in a vessel with a small opening that can't accommodate it, it's going to push up from the sides, break it. And I started our lab report and lab assignment and lab description with a news article I found from Australia, where a number of students, it's from a while back, 2007 or 2014, I forget the date, where a number of students were injured when a chemistry professor did this demonstration without proper safety precautions. And he was probably trying to make a big snake and do more than he should. That's why I like to call this the carbon souffle experiment. So there it is. I will post a separate discussion. It is still expanding slightly. It is pushing up. I'll give it another couple seconds. Here you can, if you look closely, you can see it expanding and rising out of that beaker. And what's left is pure carbon, okay? I'm going to do a couple of things. So let me show you the cleanup and the safety features that we have. These are the ones from the other day. And at this point, that beaker's hot. So I'm going to use beaker tongs to grab my beaker. Not completely sure the reaction is over. I guess it is. And I'm going to plunge it into some water with some other leftovers from the other day. You can hear it sizzling, and it's going to do several things: cool it down and dilute that acid out. And in so doing, leave it much safer. And there went half of it, and there went the other half. Okay? I'm going to, again, rinse this as water to both cool it down and to dilute that strong acid away. And I'm going to leave it, my sink, as the first step in cooling it off. And the other thing I'm doing is taking our baking soda, come on over here and we'll get this on camera, and neutralizing that. This is a classic elementary school volcano reaction where you add baking soda to acid. Usually use vinegar and acetic acid, but we have sulfuric acid. But I'm going to add enough of this until it stops bubbling and neutralizes that acid, so that I can, let me get that away from the hole, so that I can grab these, wrap them in newspaper, throw them away, and dispose of the water with a large excess. So this water that's coming over is water that's bubbled up and already been neutralized by it. Normally I would add it more slowly. I wanted to do something dramatic. So I will post, as I said, no more of me cleaning up the mess. There's a lot of behind the scenes work here. But I will post another video where I briefly go through and discuss the answers that are expected in the lab report. So until then, goodbye now and stay safe.